Hello, this is Mr. Sama again with another homework video for you. Today we're going to be talking about solving and graphing inequalities. I'm going to assume graphing inequalities has been talked about in class, so mostly we're going to deal with solving inequalities, but we will be graphing all of our solutions because inequalities have an infinite amount of solutions. We have two learning objectives for you today. First of all, we just want you to be able to solve and graph any inequality. Any inequality that you walk in and your teacher puts in front of you, I want you to be able to pound through it and have a decent idea of what the answer should be. We also want you to understand the similarities and differences between equations and inequalities. Solving these things is going to look very, very similar, but there are also differences, such as equations have a single solution, inequalities have an infinite amount of solutions, which is why we graph them. We want you to understand those differences and be able to discuss it. Excellent. Let's jump straight into examples. Examples for solving inequalities. Well, starting here, I have 0.7 is greater than or equal to 0.4 plus x. Well, I know just like an equation, I want to get x all alone. So I'm going to go ahead and look here and say x is being added to a 0.4. The opposite of that is subtracting 0.4. So I do it to both sides. And notice I'm just treating this inequality as if it were equals. 0.7 minus 0.4 is 0.3. Greater than or equal to comes directly down, the same as equals would. X goes right here. Oftentimes with an equation, if you're getting 0.3 equals x, you just flip things around and say like x 0.3. Notice that these are now saying different things here. You can flip your inequality around as long as you are careful. This was pointing at the x is smaller, 0.3 is bigger, so when I repeat it, it had better point at the x and make the x smaller and 0.3 bigger. So I can flip it around if I do this. Both of these are perfectly acceptable. I wouldn't care which one you gave me. Then we'll go ahead and graph the solutions on a number line. Here would be 0. 0.3 is between 0 and 1, so I'll just put 1 up here, and I'll say 0.3 is somewhere around there. So that's where I'm going to mark. I do have an equals to, so I'm going to fill this in because it is possible to equal 0.3. And then I'd look here and say the Pac-Man is eating 0.3, 0.3 is bigger, the arrow is pointing at x, x is smaller. Maybe your teacher has even talked about this type of thing, where if you take this and try to write less in it, this does say less. So x is less than, which means I want my x's to go down. And that'd be it. We'd be finished with this example. This next example, there are many different frameworks that different teachers have talked about. So one way, if you are comfortable with doing this, is going to be when you see things like this, you may want to multiply by the reciprocal. So I can take my 2/3 and I know I'm going to go to this side, multiply, flip this over. Over here, multiply, flip it over. When you do that, now I have a 2 on top and bottom, so those cancel and go away. I have a 3 on top and bottom, so those will cancel and go away. When I bring this down, x is already all alone. On this side, I just have to do this stuff. 6 times 3 is 18, divided by 2 is 9. And that's it. Again, I could flip this around if I wanted to, but I have to make sure the Pac-Man is eating x, the arrow is pointing at 9, keep things going the same direction. Now, if I use this trick to tell which one is bigger, I can try to write less in it. This is pointing the wrong direction. This does not say less. That means x is not less than. So x must be greater than 9. So when I go ahead and graph it, I can have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to leave my dot wide open because I do not have equals to here. And then x is not less than, x is greater than, the Pac-Man is eating x. However you think about that, x must be bigger than 9, and so our graph looks like that. I'd like to back up and look at this a second time with a different framework. A different framework that some of your teachers have talked about is when you had equations, a lot of you were much happier saying, doing these drawings. I'm going to let that thing be x. I want 2/3 of x, because that's what this is telling me, is I'm looking at 2/3 of x. So, there I cut x into thirds, and I want 2 of those thirds. Those 2/3 are 6. This is how we were taught to draw things in class. Then if I want to find out how big this x stuff is, I've got to split this 6 apart. Both of these make 6, so each of them are 3, which means this third one must be 3 as well. So now I can come back up here and finish this. The sign comes straight down exactly the same, and these things go up to make 9. This is a little bit stranger when you get to inequalities. It doesn't quite feel as solid to me as it does when we're looking at equations, but if you learn to apply it well, that's perfectly fine. It'll work every time. Again, I could flip this around if I wanted to, but make sure things are still going the correct direction, and we'd have to graph things. Your teacher may accept this instead. If you just put 0 somewhere, put the number you're comparing to, empty dot, because we are not equal to, and then x is bigger, so I want things to go bigger than. That would be finished. Excellent. Multi-step inequalities. These are going to work the exact same way we would expect them to, just if we pretended they were equations. We only have to be careful about keeping things on the correct side, because with the inequalities we can't flip sides the way we can with equations. So, f is here. I know I'm going to have to divide by 4, and I'm going to have to subtract 160. Following PEMDAS backwards, we would subtract the 160 first. Those cancel. 4f is all that's left on this side. The inequality comes straight down. 500 minus 160 is 40340. Then I'll divide by 4. All that's left over here is f. And now I actually have to divide those. Well, let me see. 4 would go into 320 80 times, so I think that is 85. Lastly, I'll go ahead and graph our solutions. Depending on how detailed your teacher wants these, they may accept if you just put 0 somewhere. 85 is your comparison number, 85. I'm going to go ahead and leave the dot empty because I do not have an equals to. And f is greater than, so I'm going to be going up. Last example for multi-step inequalities. This was something that was a 2-step. There was no simplification and no simplification, so we just go straight into solving. Here I actually do have simplifications. I'll go ahead and draw the bar in the middle first. But I can start simplifying this side. Negative 3 multiplies in. Negative 3 times 3 makes negative 9. Negative 3 times negative x makes positive 3x. And now I've simplified everything I can on that side. On this side I can also simplify things. 4 squared makes 16 minus 1. I'll bring my sign straight down. But I'm not done simplifying here. I can combine these like terms. They make 15. Sign comes straight down the exact same way. Negative 9 plus 3x. Now I'm done simplifying on this side, and I'm done simplifying on this side. So now I'm going to go ahead and begin solving. X is here. I'll have to divide by 3. But first, I'll add 9 to cancel out the negative 9. These cancel. 3x. 15 and 9 make 24. Bring down the sign exactly how it is. Go ahead and divide. X 24 divided by 3 gives us 8. And then lastly, I will graph my answers. 0, there is 8. I do not have equals to, so I'll leave it empty. And my x is less than, so I will draw this in. That's all we have to add tonight for solving inequalities. We want you to go ahead and try these 3, bring them into class, and we'll discuss them as a group. Best of luck. Have an excellent night.